Welcome to our deep dive into a critical yet often overlooked component of every centrifugal pump, the bearing. These small but mighty parts are the backbone of pump reliability, quietly working behind the scenes to ensure smooth operation. While impellers and casings usually get all the attention, it's the bearings that silently keep everything running, absorbing loads and reducing friction day in and day out. Without healthy, well-maintained bearings, your entire pump system would quickly grind to a halt, leading to unexpected breakdowns and costly repairs. That's why understanding why bearings fail is absolutely essential for anyone who wants to avoid expensive downtime and keep their operations running efficiently. Today, we'll explore the vital role of bearings, the real-world reasons they fail, and most importantly, how you can prevent these failures before they start. Think of this as a forensic investigation into machinery failure, where every detail matters and every clue can help you avoid future issues. Our goal is simple: give you the knowledge and tools to spot problems early, before they escalate into disasters that halt production. We'll cover everything from proper lubrication and installation techniques to routine inspections, each a crucial piece of the reliability puzzle. Whether you're a seasoned engineer with years of experience or a student just starting out, you'll find practical, actionable tips you can use right away. By the end of this chapter, you'll know the early warning signs of bearing failure and how to keep your pumps running smoothly and efficiently for years to come. Let's make the shift from reactive repairs to proactive reliability, saving you time, money, and the frustration of unexpected breakdowns. A bearing is a crucial machine element that reduces friction between moving parts, allowing them to move smoothly and efficiently. It also constrains motion to what's needed, guiding the shaft and preventing unwanted movement that could cause damage. In pumps, bearings play a vital role by supporting the high-speed shaft, holding it steady both radially and axially, even under intense operating conditions. They carry not only the weight of the shaft and impeller, but also absorb the hydraulic forces generated during pumping, ensuring everything stays aligned. Without bearings, the shaft would grind directly against the housing, causing instant and catastrophic failure, often resulting in expensive repairs. Bearings come in two main types: anti-friction, rolling element, and hydrodynamic, sleeve, each designed for specific pump needs. Anti-friction bearings use balls or rollers and are found in most pumps. Ball bearings are best for high speeds, while roller bearings handle heavier loads and shock. Hydrodynamic bearings, on the other hand, use a thin film of oil to separate the shaft from the housing, making them ideal for large, high-energy pumps that run continuously. Each type has unique strengths and specific lubrication needs, which must be matched to the pump's application and environment. Knowing your pump's bearing type is the first step in proper maintenance, helping you choose the right lubrication and service intervals. The right bearing, when properly cared for and maintained, keeps your pump running efficiently and reliably for many years, minimizing downtime. Neglect or misuse, however, leads to rapid, costly breakdowns and can even cause total pump failure. So regular inspection and care are essential. Most bearing failures aren't due to manufacturing defects, they're caused by external factors. Simply swapping out a failed bearing without finding the root cause guarantees repeat failures. The main culprits: improper lubrication, contamination, misalignment, and poor installation. Overloading and excessive vibration also play major roles. Less common, but still critical, are electrical damage and simple fatigue. Treat every failed bearing as a clue. Investigate lubrication, alignment, and contamination. Addressing the real cause transforms maintenance from reactive to proactive. Prevention starts with understanding these failure modes. Lubrication is the single most important factor in bearing life, acting as a protective shield. It forms a microscopic film that prevents metal-to-metal contact, reduces friction, and dissipates heat, ensuring smooth operation. Too little lubricant leads to rapid wear and tear. Too much, especially grease, causes churning, heat, and eventual breakdown. Always follow manufacturer guidelines for lubricant type and amount to avoid costly mistakes. Greases and oils aren't interchangeable. Each is formulated for specific speeds and loads, tailored to unique requirements. Mixing greases can cause breakdown and loss of lubrication, leading to catastrophic failures. Relubrication intervals depend on speed, temperature, and contamination, factors that vary widely across environments. Hot, dirty environments need more frequent attention to maintain optimal performance and prevent damage. Time-based schedules are common, but condition-based monitoring, like ultrasonic analysis, prevents both under and over lubrication, optimizing maintenance. The right lubricant in the right amount at the right time is key to extending bearing life. Neglecting lubrication is the fastest way to destroy a bearing, leading to costly repairs and downtime. Make lubrication a priority, not an afterthought, to ensure long-term reliability and efficiency. It's the cheapest insurance for pump reliability, safeguarding against unexpected failures and ensuring smooth operations. Contamination, dirt, dust, or water is a relentless enemy of bearings. Even tiny particles cause dents, leading to surface fatigue and spalling. Water displaces lubricant, causes rust, and can halve bearing life with just a trace. Protect bearings with effective seals and clean handling of lubricants. Misalignment is another silent killer. Just a few thousandths of an inch off can create damaging forces. Precision alignment, using laser tools, and accounting for thermal growth is essential. Regular checks after maintenance keep things in line. Don't let contamination or misalignment silently destroy your bearings. Prevention here saves huge costs down the line. Running a pump away from its best efficiency point overloads bearings with excessive forces. High vibration, caused by imbalance, misalignment, or structural issues, quickly destroys bearings. Regular vibration monitoring catches problems early. Improper installation is a common cause of early failure. Never use hammers or punches. Use bearing heaters or hydraulic presses for mounting. Ensure shafts and housings are clean and within tolerance. Out of round housings or wrong shaft sizes distort bearings and cause rapid failure. Measure everything and follow manufacturer specs. Proper installation and monitoring are non-negotiable for bearing life. In a chemical plant, a cooling water pump suffered repeated bearing failures, causing costly shutdowns. The team replaced bearings and did quick alignments, blaming bad parts. A reliability engineer investigated and found over-greasing, poor installation with hammers, and water contamination from washdowns. Grease analysis showed high water content, enough to destroy bearings. The fix was simple: switch to laser alignment and upgrade to bearing isolators to keep water out. After these changes, the pump ran over 3 years without failure. The plant saved millions by addressing the root cause, not just the symptom. This story proves the value of proper maintenance and root cause analysis. Don't get stuck in a cycle of repeated failures. Solve the real problem. Small changes can yield massive savings. Reliability starts with attention to detail. Pump bearing health is no accident. It's the result of proactive, informed maintenance. Most failures are preventable. Focus on lubrication, contamination control, alignment, and correct installation. Don't just replace parts. Find and fix the root cause. Learn to spot early warning signs, temperature, noise, and vibration changes. Master the basics to turn maintenance into a value-adding activity. For students, this is real-world engineering in action. A proactive approach pays for itself many times over. World-class reliability is built on fundamentals. Keep bearings clean, lubricated, and aligned.